In this video, we're gonna answer the following question. Is this series convergent or divergent? We can use many different tests to see or to answer this question. But here, using the ratio or the comparison test would require a bit of work, and we need to have some lower bound or upper bounds to see what we can do. But in our case, we can just use the integral test and see where we can go. So if we denote this one, the general term of the series by this one, 1 over n, the natural log of n times the natural log of the natural log of n. Okay, so this is a general term, and here, starting from 3, that's fine. We can start from 2 as well. So this, we can see that the an is positive. It's decreasing. Okay, it's decreasing, and to see that, you have to compare an minus 1 plus 1 with an and to get a negative sign. It's decreasing. You can check it, and also it's positive. It's positive. It's positive, decreasing. And to compare it with a function, we need to have the function an, that's f of n. Okay, the function has to be continuous, positive and decreasing. So if we let f of n equals this one here, 1 over n times ln of n times ln of n, then this function is positive, decreasing and continuous on this interval 3 plus infinity. Therefore, according to the integral test, this series is convergent if only if this integral from 3 to infinity of 1 over x ln of x ln of x dx is convergent. If it is convergent, then the series is convergent. If it is divergent, the series is divergent. Okay, the problem is, how can we find a primitive of this one? But that's not a big deal here, because we can eyeball the derivative. There are techniques that we can get this one here. But if we let g of x equals ln of x, and you differentiate this one, you will get this one. That means an antiderivative of this one is this. Okay, and now we have the value, we have the function, so we can integrate. Okay, so check that when you differentiate, you get this one. Therefore, okay, we can get this one by definition is the limit as, let's call this one f of x. Okay, this one is the limit as x goes to infinity between 0 and s f of x dx. Okay, but now a primitive is this one, so I have the limit as x goes to infinity of ln of x. Okay, well, let me call it s here, f of s ds, and let me call this one x. Okay, to make it easier. So this is s, this is x. Okay, to be standard. Okay, so here I have this limit of ln of x. This is 3, sorry, here it's 3, not 0, because 0 is not defined, minus ln of 3. Okay, so as x goes to infinity, so the limit here since this function is continuous, the limit is infinite. So we have plus infinity minus 3, which is plus infinity. Okay? This means that my series is divergent. Okay? Because the integral test is divergent, and therefore the series here is divergent according to the integral test.